Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 239. Please turn to it. Page number 239, and today is our lesson number 338. This problem that you see there on the top of the page 239, 2.8.5, the one dealing with the parabola, is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single math problem from this first edition. If you're interested in watching the original solution, you will find it on day number 123 and 124, where we did the same problem at a much slower pace in much greater detail. Today we're going to do a simpler version of it. Here's what it is. We are being asked here, it says find the intercepts, vertex and the line of symmetry of this parabola. Intercept, vertex and the line of symmetry. Of course in the real exam they're not going to ask you for everything here, they're going to ask you one of those three things. Let's get going. Well, finding the, we're going to start with the simplest thing first. Finding the y-intercept is very easy. It's very easy. That's where x is equal to 0. That's where x is equal to 0. If somebody asks you to find the y-intercept of a graph, for example, I'm going to draw a graph right now at random. Okay, watch. I'm just going to draw it at random. Here's the graph. Where is the y-intercept? Well, it turns out this particular graph has several y-intercepts. There are several places where this graph cuts the y-axis. It cuts the y-axis here, 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 and down here. It has several y-intercepts. 1, 2, 3, 4, 5. It has 6 y-intercepts. How many x-intercept does it have? X-intercept is where the graph cuts the x-axis. It cuts the x-intercept at only one location. But anyway, the point is, wherever the y-intercepts are or is, whether there is one y-intercept or more than one y-intercept, the point is, the x-coordinate of all of these points is 0. That's where y-intercept means it cuts the y-axis. Wherever the graph cuts the y-axis, the x-coordinate is 0. It's very simple. That's where x is equal to 0. We just simply take our equation, x squared minus 2x minus 3, and we set the x equal to 0. 0 squared times 2 times 0 minus 3. There you go. There's your y-intercept. Y equal to 3 is our intercept. Apparently it only has one y-intercept, and that y-intercept is y is equal to negative 3. Let's plot it, shall we? Now that we know a little bit about our picture here, let's plot it. So our y-intercept is, it cuts the y-axis at negative 3. Y equal to negative 3 is our intercept here. 1, 2, 3, that's right here. That's our y-intercept. And of course the coordinates are going to be 0 and negative 3. 0 was not the surprising part because that's why it's called the y-intercept, as we said already several times. The x-coordinate of the y-intercept is going to be 0 because it cuts the y-axis. Finding the x-intercept is going to be a little bit more involved. I need the room, obviously. To find the x-intercept, there are going to be two of them. We set y equal to 0. Because x-intercept is where it cuts the x-axis. Wherever it cuts the x-axis, if we have a graph here and it cuts the x-axis, all of these points where it cuts the x-axis, not this one, 1, 2, 3, 3 places where it cuts the x-axis, in all of these places the y-coordinate is 0. So we're going to set y equal to 0 in this equation. We are told that y equals to x squared minus 2x minus 3, that y has to be equal to 0. If you're looking for the x-intercept, the y has to be equal to 0. So we set the equation equal to 0, and we just solve for it. Now listen very carefully, okay? Listen very carefully, pay close attention here. What I'm going to do in the next 3-4 steps, is only going to take a few seconds. Okay, as I said, listen very carefully. It's going to take only a few seconds for those people who understand, who are familiar with the concept of what is known as factorization. If you are not familiar with the concept, or if you are not very good at it, it is very, very important that you familiarize yourself with the concept of factorization thoroughly, because you're going to come across several problems in the exam where you will be required to use that concept. Here, in the blackboard, you see a list of all the videos that you will find. There are several of them where you will find plenty of practice. Day 312 to 315, 312, 313, 314, and 315. There's 4 of them right there. 141, 142, that's 6 so far. 124, 129, that's 8 so far. And then 99 through 103. So there are a dozen videos that you can watch. It will give you ample practice on factorization. Here, I'm not going to explain every single step. I'm just going to assume, I'm just going to take it for granted that you are familiar with the concept and that you know how to factorize. So let's get going. So we're looking for factors, we're looking for 2 numbers such that their product is -3. We're looking for 2 numbers, such that their product is -3, and we're looking for 2 numbers whose sum has to be -2. That's how we find the factors. Can you think of 2 numbers? Can you think of 2 numbers so that when we multiply them, we get a product of -3, and when we add them, we get a -2. And this is where the tricky part comes in. This is where the practice comes in, because otherwise, if you, as I said, if you don't practice, it can take you some time to come up with those 2 numbers. Those 2 numbers are, and if you like to pause the video at this time to actually think of 2 numbers yourself, that actually is not a bad idea. Why don't you pause the video right now and think of 2 numbers that I'm talking about. Their product has to be -3, and their sum has to be -2. Those 2 numbers are -3 times +1. -3 times +1 gives us -3, and -3 plus a +1. -3 plus a +1 will end up in -2. -3 plus +1. Those are the factors here. So let's do that here. In other words, we're going to break up our -2x into 3x, a -3x, and a +x. A -3x and a +x is going to give us our -2x. So x squared minus 3x plus x minus 3. As you can see, -3x and a +2x gives us our -2x in the middle there. And if I lost you already, then you need to watch those videos. What's the common factor between these 2 terms? The common factor is x. Take it out, and we get x minus 3 here, because x times x is going to give us our x squared, and x times 3 is going to give us our -3x. What's the common factor between x and a -3? X and a -3 has nothing in common except 1. 1 is the only common factor. But then again, that's a theoretical curiosity, because 1 is a factor of everything, obviously. Anything can be divided by 1. So if you take out the 1 as a common factor, what we're left here is the thing itself, because 1 times x is going to give us our x, and 1 times -3 is going to give us -3. Now we look at these two terms, and we ask ourselves, what's the common factor in these 2 terms? Again, as I told you, I wasn't going to explain everything, but there we go again. I shouldn't have to do all of this thing. The common factor in these 2 are x minus 3. Take it out, and we get x plus 1 here left over, and that whole thing has to equal to 0. This whole thing has to equal to 0. So now we have 2 quantities. X minus 3 is one quantity, and x plus 1 is another quantity, and we know that their product is equal to 0. The only way the product of 2 quantities can be 0 is if either x minus 3 is equal to 0 or x plus 1 is equal to 0. If someone tells you that a times b is equal to 0, then either a is equal to 0 or b is equal to 0. There is one more possibility, which is maybe they are both 0, which is also going to work, because 0 times 0 is 0, obviously. So if x minus 3 is equal to 0, that implies that x must be positive 3. If x plus 1 is equal to 0, that implies that x must be negative 1. There you go, we found our 2 intercepts, positive 3 and a negative 1. Positive 3 and a negative 1. Our map is so crowded here that this graph is going to be very difficult to look at, but that's okay because in a second I'm going to erase everything except the graph. So here are intercept positive 3, 1, 2, 3, positive 3 and a 0 and a negative 1. We're getting very close to getting done. That's it. We have found the y-intercept, we have found the x-intercept. Now let's worry about the vertex. Let's worry about the vertex. I need the room, so I have to erase everything. I'll give you a second in case you need to pause everything. Here we go. Before we can find the vertex, even though this is listed second in the list, before we can find the vertex, we have to first find the line of symmetry. Finding the line of symmetry is a very simple process actually. It sounds complicated, but it's not. Look, we have an. Why don't we plot this thing up here? Why don't we plot this thing up here? We have a 1, 2, 3, a negative 3, 0, and a negative 3. And then we have positive 3, 1, 2, 3, and a negative 1. 0, sorry, negative 1 and 0, and positive 3 and 0. So we have our x-intercept, these are our x-intercept, this is our y-intercept. Now let's talk about the line of symmetry. It'll be easier to look at it here. Finding a line of symmetry is actually very simple. Count from here, from negative 1 to positive 3 is how many units? From negative 1 to positive 3 are 4 units. Negative 1 to 0 is 1, then 2, then 3, and then 4. Of course, there are 4 units. In other words, the line of symmetry, is going to be x equals to positive 3. We take the average of these two numbers, this and that, positive 3 plus a negative 1 divided by 2. Why the average of those two? Because the line of symmetry is so called because everything is symmetric around it, which is why it's called line of symmetry. Everything that you see on the left hand side is the exact mirror image of everything that you see on the right hand side. In other words, the line of symmetry cuts the graph in two identical halves. Where is it going to cut the graph? Where is the midpoint between negative 1 and positive 3? The midpoint is right here. Right here. We don't have to do all of this mumbo jumbo. This is childish. What I'm doing here is childish. We shouldn't have to do this. We should be able to see very quickly that the midpoint of negative 3 and a positive 3, negative 1 and a positive 3 is 1. As you can see, positive 3 and a negative 1 is going to give us positive 2. Positive 2 divided by 2 is 1, of course, which is not a surprise. X equal to 1 is our line of symmetry. The equation of the line of symmetry is x equals to positive 1. Are you with me so far? Very good. That's it. We're done with that part. Let's move on, and now we're going to talk about the vertex. We're done with this part. I need the room. I'm going to... Vertex. Vertex is the lowest point on the graph. But the point is, listen very carefully. This is what you have to understand the concept. The point is, we don't know what the coordinates of the vertex are, but we do know the x-coordinate of the vertex, because the vertex is so called because the lowest point of the parabola that we're looking for is going to fall on this line of symmetry. Because you see, here's, I'm going to draw, there is a parabola. I'm not going to draw x and y axis. Here is the line of symmetry. There is the lowest point. So the lowest point, the vertex, has to fall on the line of symmetry. It has to cut the line of symmetry. That's why it's called the vertex, because this half is mirror image of that half. We already know the x-coordinate of this point. X-coordinate of that point is 1. It cuts here, 1 and what? That's what. Where is the y? Where does it cut on this thing? Does it cut it down here? Does it cut it down there? Does it cut up here? Where does it cut it? Well, we're going to find out. How are we going to find out? So substitute to find the vertex. Let's do it up here. To find the vertex, substitute x equal to 1 in the equation. To find the y coordinate of the vertex. To find the y coordinate of the vertex. I'm explaining way too much here, I shouldn't have to. So here's our equation, y is equal to x squared minus 2x minus 3. We are almost done. Substitute x equal to 1 in this thing. 1 squared minus 2 times 1 minus 3 is going to give us 1 minus the 2 minus the 3. A negative 2 and a negative 3 is negative 5. Negative 5 plus a 1 is going to be negative 4. Voila. Y is equal to negative 4. This is 1, 2, 3, so 4 is going to be down here somewhere. Let me erase this part here, it's in the way. So this is the y-intercept, and this is negative 4 here. This is the vertex. The vertex of this vertex is positive 1 and a negative 4. Positive 1 and a negative 4. That's it, we're done. There we go. Our parabola that we're looking for looks something like this. It's not going to come out very nice, but that's okay. It's supposed to be symmetric and it's supposed to be nice looking. Mine is an atrocious looking, a hideous looking parabola. It's just the way, it's just because I'm not very good at drawing things. But anyway, we're done. I'm going to do it freehand instead of being so timid, instead of being so timorous. I'm just going to go for it. Voila. This parabola that you see there, is the exact same thing that you see in the book. So anyway, one more time, what's going to happen in the exam is that you'll be given an equation of the parabola and you're going to be asked to find one of those three things. They might simply ask you what's the equation for the line of symmetry, and it will be a multiple choice question. And there are going to be several answer choices. Of course, you can count on the fact that one answer choice is going to say x is equal to 1 because that is the correct answer, but one of the other answer choices is going to say y is equal to 1, and then several other answer choices that the three other most common mistakes. And of course, the correct answer is x is equal to 1. Or they might ask you for the coordinates of the vertex, and again they're going to play with your mind. One answer choice, of course, is going to be positive 1 and negative 4, but you can count on the fact that one of the answer choices is going to be negative 4 and positive 1. You have to be careful, and of course, three other answer choices containing three most popular mistakes. Or they might ask you simply the coordinates of either the one of the x-intercept or maybe the y-intercept. Depends on what they ask you. But anyway, this is what's going on here. All right. I will see you tomorrow, where we'll talk about circles. Bye now.